Food facts: 7 things you didn't know about your food. Ever wonder why bread dough rises? Well, bread is made up of several ingredients such as flour, yeast, a liquid, and salt. Each ingredient, however, has its own role in bread baking. Flour, which gives bread its texture, is made by milling cereal grains such as wheat, barley, or rye. The grain seeds are then crushed, releasing starch and proteins. Starch molecules are long, gangly polymers of simple sugars linked head to tail by chemical bonds. Proteins contain tons of amino acids strung together. What gives bread its slight, fluffy texture? It comes from 2 proteins, gliadin and glutenin, found in flour. When flour and water is mixed and kneaded, these proteins swell up and form a tough elastic substance called gluten. Gluten in turn can stretch and trap the gas that makes dough rise. But where does this gas come from? It comes from yeast. Yeast, flour, and water, when mixed together, create a sticky white dough. Because of this, there is fermentation and molecules are still moving. Enzymes from the yeast attack the starch, breaking it down to glucose. Other enzymes transform glucose to carbon dioxide and ethanol. CO2 bubbles up through and lets the dough rise. But what is the difference when it is leavened by baking powder or by yeast? When leavened by baking powder, you have a different taste from bread leavened by yeast because the chemical reactions only produce CO2, salt, and water. However, when it is leavened by yeast, yeast cells grow under anaerobic conditions, which means that this is a process that takes place in the absence of oxygen. It cannot convert glucose completely to gas. Therefore, sugars are then sometimes converted into alcohols, acids, and esters, which add to the bread's flavor. So, what happens? Salt strengthens gluten, which slows down the enzymes, which catalyzes the breakdown of proteins. Too little salt and the dough becomes tough and sticky. Too much, and water flows out of yeast cells by osmosis. Nutrients are lost, and production of CO2 slows down. So, dough rises after a couple of hours in a warm place. Then your dough is oven ready, so heat causes pockets of gas, or the bubbles in the dough, to expand, which follows the ideal gas law of PV-nRT, where volume is directly proportional to temperature and pressure is also directly proportional to temperature. The crust turns brown and, well, your bread is ready.
Aren't you curious to know what you're drinking? What's really in your orange juice? When we go to the grocery store, to the aisle of drinks, and see 2 kinds of orange juice, one powdered drink and one 100% orange juice, which one do we take? Being the unaware people that we are, we take the latter, thinking it's healthier and more organic. We think that these juices are basically just the squeezed juice from oranges. No more, no less. Why do they taste different depending on the brand then? More so, why do they taste the same each time you get them from the same brand? Well, that's where we are outsmarted by these companies. Oranges are actually squeezed to get their juices. However, after being squeezed, oxygen is removed from the extract. This is to prolong its shelf life and sell them longer in the market. As the oxygen is being removed, the natural flavors of orange are removed as well. As an effect, it wouldn't taste nor smell the same. So, what these companies do, they hire flavor and fragrance companies to create flavor packs to make the liquid smell and taste like orange juice. However, these flavor packs are made out of orange byproducts, so they are not required to be put in the label, which makes it legal for these companies to sell them as 100% orange juice. And there you go, what's really inside your orange juice. In the end, nothing would still beat the old-fashioned juicing on your own.
The science behind alcohol. The type of alcohol that is in the alcoholic drinks we drink is a chemical called ethanol. Alcohol is made by a process called fermentation. It is when yeast or bacteria react to the sugar in food, like different kinds of grains, fruits, or vegetables. The process of fermentation then produces ethanol and carbon dioxide. Wines and ciders are usually made by fermenting fruit, while beers and spirits are typically made of fermented cereals such as barley and rye. Alcohol content is affected by how long it is left to ferment. On the other hand, spirits go through a process called distillation, where water is removed, leaving a stronger concentration of alcohol and its flavor. When going on a night out, beer has the lowest alcohol content by volume, followed by wine and then liquor. A 2007 study found that alcohol was absorbed far more quickly when mixed with a carbonated beverage compared to flat mixers such as juices. Carbonated alcoholic beverages include champagne, sparkling wine, beer, and some flavored spritzers. The magic really happens in the stomach rather than in the drink, because carbonation increases pressure in the stomach, which then helps force alcohol into the bloodstream through the stomach lining. So if you feel a bit bloated while having a carbonated alcoholic beverage, this discomfort is actually the feeling of you getting intoxicated faster. But what will get you intoxicated faster than a soda mixer would be its diet artificially sweetened counterpart. The sugar in soda and juice mixers slow down the absorption of alcohol in the stomach compared to the artificial sweetener, which is treated as food in the stomach, so the lack of sugar allows a faster rate of absorption in the bloodstream. Drink responsibly.
In this segment, we will be discussing the chemical effects of chocolate on the human person. First off, with the human mind. Now, we know there are many chemicals that trigger the release of endorphins throughout the human body, which we all know instigates pleasure and well-being. One of them is tryptophan, an amino acid which is needed to generate serotonin, which we know as the brain's happy chemical. Serotonin is responsible for the feelings of joy and happiness that one experiences after eating chocolate. Another noted chemical is anandamide. It is thanks to these two chemicals and a combination of others that make chocolate a viable option for consuming when in emotional distress. Now for the heart and other body functions. We have flavonoids and phenolic phytochemicals that reduce blood clot and decrease hypertension in the human body. They're also a good source of antioxidants. Chocolate is also a source of minerals like magnesium, potassium, and phosphorus. Magnesium, of course, is responsible for the metabolism and well-being of our human bodies. In a given amount of dark chocolate, there's about 25 to 50 milligrams per bar. However, chocolate is also known to sacrifice or compromise healthiness just for the sake of taste. There are fats and sugars that increase calories and therefore increase the risk of obesity. For example, there are 500 calories in a 100 milligram bar, and in turn translates into a low GI of 22 for dark and 40 to 70 for milk and white chocolate. But outweighing the cons, chocolate is a viable source of energy.
Everyone loves bacon, but there's something about bacon smell that gets us even more excited before actually tasting it. Here's why. Bacon gods put together a total of 150 organic compounds that contribute to its smell. By means of Maillard reaction, amino acids and sugars react together. In fact, this phenomenon is responsible for the golden brown color of anything you devour. Steak, bread, eggs, dumplings, name it. But when Maillard reaction occurs in bacon, it also produces the aroma compounds, which are basically hydrocarbons and aldehydes. Let's break it down for you further. The hydrocarbon chains made of hydrogen and carbon atoms produce a sweet smell that we all associate with bacon. Similarly, aldehydes give the same effect with added oxygen atoms attached to its chains. But the most credit goes to nitrogen. Compounds pyridine and pyrazine hold these nitrogen atoms that give its meaty aroma. So there you have it. Throw in a little pyridine, pyrazine with some hydrocarbons and aldehydes and savor in the yummy sensation that smell of bacon.
Why do we salt our pasta water? That's a question we always consider when boiling noodles. Cookbooks usually ask us to add salt to boiling pasta water to speed up the cooking process. So, does adding salt to water lessens the time it takes for water to boil? Or does it do the opposite? We'll see in a jiffy. The boiling point of a substance is the temperature needed for it to change from liquid to gas state. In the case of regular, unsalted H2O, commonly known as water, its boiling point is 100 degrees Celsius, or about 373 degrees Kelvin. When we add salt into the solution, its boiling point increases slightly for every molecule added. But why does salt water take less time to boil compared to fresh water? Well, the answer is found in the equation Q equals mc delta T, where Q is heat energy in joules, m is mass in kilograms, C is an object's specific heat, joules per kilogram Kelvin, and T is its change in temperature in Kelvin. Let's look more closely. Water has a specific heat of 4,185 joules per kilogram Kelvin. Salt, on the other hand, has about a fifth the specific heat of water, which is about 880 joules per kilogram Kelvin. See here that by adding more salt into the salt water solution, its specific heat decreases as the solution increases. If we are to rearrange the equation into Q over mc is equal to delta T, we see here that a decrease of specific heat in a substance means that less energy is needed to raise a substance temperature by a degree should all else remain constant. So despite increasing the water solution's boiling point slightly, adding more salt also greatly decreases its specific heat. And thus, boiling occurs at a shorter amount of time. So back to the question, why do we salt our pasta water? The answer simply is that it would allow the solution to heat up at a faster rate and maintain a higher boiling point. By having pasta cooked at a hotter temperature, cooking is sped up. So next time you cook your spaghetti noodles, never forget to add salt. Thank you.
Have your muscles ever felt sore and painful after a good hard workout? And you just feel like collapsing on your bed? Well, the answer to your problems might just be the watermelon. Well, its juice at least. In a new study, scientists have found that drinking watermelon juice may help alleviate muscle soreness, and it may even boost athletic performance as well. You see, scientists found that the amino acid L-citrulline is found in watermelon juice promotes blood flow to tissues like muscles. More blood means more oxygen, and more oxygen means muscles can repair themselves faster. Hence, the juice's ability to relieve muscle soreness. They also discovered that watermelon juice had antioxidant properties, the potential to increase muscle protein. Guess watermelons are great for health and fitness both alike. Scientists tested this theory out by giving 3 types of drinks to 3 different groups of test volunteers an hour before exercise. The first group was given natural watermelon juice. The second group was given watermelon juice enriched with L-citrulline. And the third group was given a control drink that didn't contain any L-citrulline at all. By the end of the test, Scientists found that the two groups who were given drinks containing L-citrulline were relieved of their muscle soreness. While the control group? Let's just say they were still pretty sore. The natural watermelon juice, however, gave better results compared to the juice that was enriched with L-citrulline. Scientists found that this was because the naturally occurring L-citrulline was more bioavailable. That's just fancy science talk for being in a form that the body could use better. So there you have it. Next time you go out for a workout and you need a refreshing drink, go for watermelon juice. Not only is it delicious, but it also helps you keep from getting sore.